Hey guys, this is Eric Weingartner with Weingartner Racing. This is a follow-up from a video I posted last Saturday. Depending on when you watch it, you can go back and watch like customer sitting ahead to give me information about what to do. Well, he finally got a hold of me, so I got to tear down the head. And it left with, if you watched that one, was a very interesting one because you saw one valve that was considerably longer than the others. So I got a chance to tear down this head. I'm going to show you everything that I kind of found, because some of it's pretty strange, and let you get an idea of what really happened, because you're going to be kind of curious on this deal. First off, the customer said that the heads were set up for a solid roller. Okay, so solid roller springs are typically stronger. So I tore them all down, checked the installed height, and there's your installed height. That's 1.920. I then checked the pressures, because that's what I like to do. That's the pressures. This is the seat pressure, 145. If you have a solid roller, typically, and this is typical, the spring pressures are usually between 200 on the seat all the way up to 265. In general, whenever you order a set it for me, they're around 245 on the seat and about 590, 600 open with my standard spring. The ones for race were usually in the 265 range and 740. That pressure is for a hydraulic roller. And even at that, a light hydraulic roller. That's not a lot of seat pressure. So one, not near enough for a solid roller. Two, if you were to ever run a solid roller, you would not use these locks. These are 7-degree locks. These are what this guy had if you watch my videos, the past one. These ones are what you find in your typical stock small block Chevy will have these locks, these 7-degree, sometimes either stamped or machine locks, and that's what people use. And by the way, it's not that they're bad, but they're used for a hydraulic roller or a hydraulic flat tappet, solid flat tappet, they work okay. I don't use them as often, except for on some street stuff. I'll use them for hydraulic rollers, I'll use them for that. But typically I try to stay with the 10-degree stuff. And what do you mean by 10-degree? Let me show you. So this is the 7-degree that pulled out. This is a 10-degree lock. Now you won't notice, and by the way, I put the halves together so you can kind of see. One, the 10 degrees taller. But what I mean by that is if you look at the 7-degree, it looks more straight than the 10-degree. And the reason why is because the 10-degree spreads the load out over a larger surface area. So it's actually able to give makes it stronger because it's spreading the spring load over a broader area than, say, for instance, the 7 degrees. Because one, it's over a shorter area and over less total length anyway compared to a 10-degree. Now, some of you might be saying, well, wait a minute. LSs use bead locks, and these little bitty ones. You're right. And most of the LSs are hydraulic rollers, and their lock's even shorter. But the bigger difference is they are bead. And what I mean by bead is, let's hold this up here. That's a square groove. See, it's cut like a square. That's common for most small block Chevy stuff. The other one is called a bead groove. And let me see if I can't find one real quick. Sorry for the delay. Let me just pull down this. Let's get out an LS lock real quick. Yeah, here we go. Oh, it fell over. By the way, I promise I'll get to the valve thing in a minute. There's your typical LS valve lock, okay? And this is a small block Chevy lock. See how it's rounded? That's a bead groove compared to a square groove. Okay? They are different. The bead groove actually makes it stronger because at the top of the valve, the square groove will try, when it's trying to, as the spring is trying to lift up, it's trying to roll that edge. It's much harder to roll with a curve, so it actually doesn't, the square will try breaking off the tip a lot easier than with a bead. Not that it happens that often, but the bead will roll and not try to take off the tip. I've seen several times where the tip of the valve's been broke off, and if it had been a bead, it probably wouldn't have happened. 10 degrees, this is a square one. We use it for a lot of stuff and really haven't had any issues, even though that's a square groove. These are still, even though it's LS, they use them on hydraulic rollers. Solid roller, they'll use a different setup altogether. Now, 7 degrees aren't the end, doesn't mean so much the horrible stuff, because they have something called a Super 7 lock. And it's a 7-degree like this, but it's much taller. It's even taller than the 10-degree. So it actually supports more of the valve area itself. And because it's longer, it can spread the load out over a bigger distance. Anyway, I just want to point that out. If you're using a solid roller, you should not be using a 7-degree machine lock like that. You just shouldn't do it. Solid roller setup shouldn't. You can get away with a hydraulic flat tap it, solid flat tap it, and a hydraulic roller, not solid roll pressures. Okay, I want to point that out first. Next thing about these heads, they did use shims underneath here to protect the aluminum, because you're not supposed to ever run a spring directly onto aluminum, because the steel spring will eat through the aluminum. So you have to have something underneath. What I don't like is, see that big old hole for the inner spring? That dude's gonna dance around on the bottom. The only thing that's supporting it is the lock at the top. And then, like I said, you just put a 7-degree lock. So not only now, you have even more pressures and strain on the top of this valve itself, because you got a smaller lock. The bottom of the spring is gonna move more, causing the top to wanna dance. The only thing holding it in is that. So it puts more stress on your lock. So the solution is using the Id Locator. Let me see if I have one handy to show you. Oh, I'll grab an LS one. Sorry for the delay. I probably should have prepared better. Extra. There we go. This is an Id Locator. This is one for an LS. So they sit in place like that, but this inner step here sits on the inside of the spring. This one clearly, oh, that doesn't fit at all, but anyway, it holds it there so it stops the spring from moving. So it's being held here at the bottom and here at the top. It's less movement at the top of the valve. It's better that way. So that's another thing I don't like. But the reason why you really wanted to watch this video was the length of the valve difference. Look at this. Let's look closely. Can you see the difference? It's noticeable, right? Well, at first I thought, well, maybe someone put in a longer valve. Nope, that wasn't the case at all. Look at the valve. This one's normal, by the way. Now look at the one in the background. You see it? You can see it. I'm gonna tell you now, let me get the camera to zoom in a little bit better. Let me get my pointer. I really should have been more prepared. I was just trying to do this real quick. Look right here. See the swoop off the stem? Now look at that. This is almost like a tulip design, so it's got a swoop down here that this one doesn't have. For the record, it's not supposed to be that way. Yeah. You want to guess what's happening? You're going to love this. This is one of the rare times when I could say a valve, if this had broke off, it would not have been because of something else. So if you ever heard me talk about when valves break, 90% of the time valves break because something got in here or hit the valve and then caused it to bend, and then finally the metal can't take it anymore and it snaps off and breaks. 90% of the time. This is the other 10%. Here's what happened. The valve's actually being sucked into the head. You doubt me? Look at the bottom. Look how it's caved in. Okay, see it's sucked in compared to that. By the way, that rings there from the valve spring compressor to take it off. It's not that it hit something. See the huge dish? Because here's what's happening. It's being sucked into the port, pulling right here on the valve, and it's stretching the valve, and it stretched the valve that it made it taller than the other. So it made it taller. So it was eventually what was going to happen, it was going to keep stretching and bam, break right there, drops the valve, boom, engine over. 10% of the failure. I rarely see this. Usually when a valve fails, like I said, it hits something. This is a Chinese valve. They're made with inferior products, and you get the idea. It starts sucking in and boom. You can even tell by the seat line. Look how high up it is. This can be a little confusing to you. Let me grab my pointer again. Right here. That's the seat line here, which is down here. The seat line on this one's all the way up here. These measure the same diameter. What's happened is it's pulling its way through. crazy. By the way, I'm willing to bet he got extremely lucky on this deal, because as the valve expands like this, because you could tell it's like this, with a solid roller setup, you've only got like 20,000 splash. This is definitely taking up more than 20,000. So as it's pulling up, it's taking up its gap. And eventually what it's going to do is it's going to keep going, and it's actually going to have no lash at all. And then it's going to transfer the rest of the load to something else, which could be a rocker arm braking, push rod braking, lifter braking. Something's going to break. But my bet is eventually, the only thing, probably reason why it didn't break, is it took up all of its lash, and that's as far as it could go. Or if he kept redoing the lash, that's what happened. So anyway, there's your answer. What happened? The valve was a cheap piece of crap, and it got pulled up into it, and you guessed it, was on the verge of failure. So also don't use 7-degree locks. There's your lesson for the day. Take care.